Bismillah ar-Rahman ar-Rahim. This video is going to be about chapter 21, collaborative construction. Alright, first of all, we're going to discuss an issue or a case that happens to almost each and every one of us. Sometimes when there is something wrong with your code and you don't know what's wrong, and you've looked it through, you thought about it, you didn't know what's happening. So you go to some other programmer, somebody's close, and then tell him that, well, I have something wrong with my code and I want you to check it. And then that person will be with you in your desk and is like looking over your code. And you'll be like, well, I tried this but it didn't work, and I tried that but it didn't work. And then you just pause and you'll be like, well, maybe it's something else. Oh, now I know. And then you actually fixed your own problem without the other person saying a word. The whole purpose of this chapter is going to be about what we call collaborative construction. What we mean by that, collaborative construction techniques is, that everybody is helping you in a group of programmers working together to enhance the quality in different ways or forms, giving different names. It could be peer programming, it could be informal checking, it's whatever. Alright, so here are the topics that we'll be discussing in this video. First, we're going to give a general overview of the collaborative development practices. Then we're going to talk about pair programming, formal inspections, some other kinds of collaborative development practices, and after all, we're going to wrap up just to revise all the concepts we've discussed. First of all, what do we mean by collaborative construction? Well, collaborative construction refers to pair programming, formal inspections, informal reviews, and document readings, as well as other techniques in which developers share responsibility for creating code and other work products. Here is the key definition, that people actually share responsibility, share time, and share their expertise in the development of the program. All collaborative construction techniques, despite their differences, many ways, but are all of them based on the idea that developers are blind to some of the trouble spot in their own work, and they need an extra set of eyes to look at it and just to find out if something is wrong with it or something might be troublesome. Alright, so first we're going to talk about some collaborative construction complements other quality assurance techniques. Well, the primary purpose, the main goal of collaborative construction is just to enhance the quality of the software that we produce. This is the whole purpose of it. So this is one benefit that you can get from actually having more than just one person working on the code, is to enhance the quality. Another benefit will be that it decreases development time, which makes sense because instead of having just one person working on the code, you can have 3, 4, or even more working on the program. So of course the development time will shrink. But one might think that, well, because you have more than just one person working on the project, that means increased cost. Well, that's true, but you should not think about it just like that, because when you have more than one person, that means, as we said, the time to develop the program will shrink. That means the total hours that the whole project will cost will be fewer, right? Plus, when you think about it in terms of bugs resolution, I mean, if you have more than one person, that means fewer bugs will be there. That means the cost of solving those bugs, if it goes, to further stages, will be cheaper. So, if you're thinking cost-wise, having actually collaborative development would be good. Many studies has been conducted to study the effect of technical reviews or formal or informal inspection, or actually any kind of collaborative development, a group of people working on code, whatever you call it. And here are some of those studies. IBM made a study in 2005, and the study found that each hour of inspection prevented about 100 hours of related work. So that shows how important it is to inspect code in order to find problems and bugs and defects before they go further down the road. Also, a company named Raytheon reduced its cost of defect correction or rework, when something's wrong and you have to actually do it again. The cost of that actually was reduced from about 40% of total project cost to about 20%. That's like half. They cut the cost in half just by doing inspections and informal reviews, and collaborative work, developers working together in order to find errors in each other's code before it goes further stages. Also, Hewlett Packard HP reported that its inspection program saved an estimated $21.5 million per year. That was in 2000. You can imagine how would it cost now. So the whole point of that is we just want to make sure that you understand perfectly how important it is to work collaboratively with other developers. That you let them look into your code, you look into other people's code. The whole point is when you have other people with you, they can find bugs or errors that you would not be able to find because you wrote it yourself. Alright, so this is the first thing we talked about, quality assurance techniques. Now we're going to talk about how collaborative construction provides mentoring, alright, in corporate culture and programming expertise. Well, software standards can be written down and distributed. You can issue it as a policy, as a rule, but unless people talk about it and people encourage each other to use it and to work with it, it's not going to be useful because nobody's going to be using it. So the importance of reviews is that if you have a coding standard, right, but nobody's really following it, if there is no way of reviewing people's work, you will not be able to know if somebody's following it or not, right? But if you review codes and you can check that, oh, you're not following this standard, you're not following that standard, you're not following that rule, and then there will be feedback, and then people will be, they feel like they have to follow the standard. So here, this is the point of review. Giving review means that people will find themselves, developers will be forced to actually follow the rule and follow the standards. Also, in addition to the feedback thing, not just feedback about standards, not just feedback about coding standards. Sometimes you need a more technical review or more technical feedback from experienced, seasoned developers. Stuff like formatting or comments about the code or variable names or local or global variables or the design or whatever. Technical aspects. So it's not just about the coding standards, it's about technical aspects in the programming code, in the writing or the coding itself. Also, we have a very important thing that we need to discuss when it comes to collaborative work, because sometimes you have junior programmers, people who just, who are not very experienced working with code. And it will be very important when you work with these people, you work with them and they see you work. They are part of this collaborative team, this collaborative work, and this will give them very valuable experience. So here's the point of the mentorship part. This is collaborative work. Experienced, seasoned developers can give and deliver mentorship to younger and junior programmers. Alright, so also we're going to discuss collective ownership. What does that mean? Well, collective ownership means all code is owned by the group rather than by an individual. So when 3 of us work together on the same code, that means I'm not the owner of the code. I cannot claim that it's mine. We all wrote it. So this is collective ownership. Okay, this is actually beneficial. Why would it be good to have a code with multiple owners rather than just sole owner? Well, better code quality arises from multiple sets of eyes seeing the code, of course. This is what we've been talking about. Because instead of having one person writing the code, checking the code, you have many people working on the code. That means instead of just one mind, one mentality, you have many mentalities working together, and this means that the possibility of finding errors or defects before it goes further is more likely. Also, the impact of someone leaving the project is lessened, because if you have only one person, right, and this person is working on a project, and then this person leaves the company, for example, before even the project is finished, or even after the project is finished, the thing is there will be nobody experienced in this particular project. So it's going to be a danger. But if you have many people working on the same project, that means if one left, right, it doesn't really make much, it's not much of a problem because others who can fill in for him. So it's kind of a security thing. Also, defect correction cycles are shorter overall because any of several programmers can potentially be assigned to fix bugs on a as available basis. Well, it makes sense because if you have only one developer, right? And then the code, let's say that the code went to testing, and the people of the testing unit worked on it, and then they found bugs, and then they assigned it to the developer. If you have only one developer, then you have this developer working on all the bugs. But if you have many developers, of course the bugs will be assigned almost on all of them. That means the time it would take to fix the defect and to launch the application or the solution, of course, will be shorter. So this is another benefit. So these are the benefits of having collective ownership of the code. Yes. Alright, now we're going to talk about pair programming. Alright, what is pair programming? In pair programming, one programmer types in code, hit the person with the keyboard, and the other person, the other programmer, watches for mistakes and thinks strategically, right? So you have the person with the keyboard, the person who's writing the code, the other person is looking, thinking, and strategically planning, as the other person is writing or typing. Okay, pair programming was originally popularized by extreme programming. The idea, the concept of extreme programming kind of evangelized the concept of pair programming, because you can just get rid of defects as as early as possible without just going the whole cycle and then waiting for it to be discovered in the testing phase. You can just, if you have somebody just by your side when you're typing, he's looking at you and he's thinking with you, and he'll be like, oh, this would be a defect, this would be an error, that looks like a bug, that will shoot most of the bugs. So this is the point of pair programming. Well, pair programming has keys to success, stuff that you have to do in order to have efficient and meaningful pair programming. The first key would be that you need to support pair programming with coding standards, because if you have the people, the pair, the programmers that are working on this, and if they're all the time they're fighting about the coding standard or the coding style, or they're always having disagreements on that, that means there is most of the time is just gone on nonsense. You have to have a standardized coding style at first. Okay, you have to have a coding standard, and it should be agreed upon within the team or the pair, and then they can start development or the coding. Also, don't let pair programming turn into watching. I mean, the other person, the person who's not on the keyboard, has to be the thinker, the person who thinks strategically, the person with good eye, the person who's looking at the other person's code and just on the fly try to think of, is this a mistake, is this a bug, could this be a defect? So it's not just about somebody's typing and the other person is watching. It's about someone's typing and the other one is focusing and thinking. So it's not just about watching. Well, the third, and actually a very key to success, is that you shouldn't force it on easy stuff. Everybody, companies and people and teams who actually practice pair programming say that it is better be done for complicated stuff, because if something is easy and simple, you don't really need two people to work on it. Maybe it's just one is enough. So you're just taking up time. But if something is complicated and it looks like it's error prone, it may look like a lot of mistakes can happen in this, then you need pair programming. But if it's simple, just one person is enough. Also, you need to rotate pairs and work assignments regularly. That means, in pair programming, you have a pair, and this pair you need them to play different roles. So this time someone would be the person who's typing the code, and the other person is the reviewer, the person who thinks, who reads, who looks at the code and thinks about it. Next time, rotate them. Let the person who used to be the thinker be the typer this time, and the other person be the person who's looking at the code and try to find out defects. Rotate. It is very important. The other key to success is what we call chemistry. Chemistry, that if you have two people who hate each other, just don't force them to work together, because sometimes personal conflicts or personality conflict can get in the way of professionality, and it might add extra problems. So you have to make sure that the people who work together in this, they have at least they can accept working with each other. There is no problems between them. Also, you need to avoid pairing rookies or noobs, people who have never done this before. If you get two people who have never ever done pair programming before, and just say that, okay, I want you to sit together and do the thing, it's not going to be very effective, because both of them have no clue how it's done. It might seem very unnatural for people, for a programmer who used to just work by himself all the time, and to have somebody by your side just looking at the screen. I mean, it might be very inconvenient for somebody who's not used to it. So when you have a pair, make sure at least one of them has done pair programming before. And also, it's very important, and it's actually the most important key, is that you have to assign a team leader, because you have to have somebody who has the final word. Because otherwise, if you just give the people the right to express themselves, but without somebody who being the decider, being somebody who's making the choice, making the call, then conflicts can go just like forever without having any productive. You have to have a team leader. You have to give people the chance, the opportunity to express themselves, to speak their mind, and then there have to be somebody whose call should be taken as the team leader. Alright, so we've discussed what pair programming is. We talked about some kind of keys in order to make it work. Then we're going to talk about the benefits of pair programming. Why would we be doing it? Well, pair programming has numerous benefits. First, it holds up better under stress than solo development, right? Because if, let's say that there is a tight schedule, you have just, I don't know, 2 days to finish up a project. If you're on alone, it's going to be much of a stress. But if you have somebody by your side, somebody working with you, somebody is checking your code while you type to make sure that there is no mistakes, there is no big bugs, there is no huge defects or misunderstandings. So you would hold better to stress than just being alone, just by yourself. So this is a big plus, actually. And it also improves code quality, of course, as any kind of collaborative development activity, because you have more than one person working on the code. That means the quality, of course, will be enhanced. Also, it shortens schedule, because pairs tend to write code faster and with few errors. And this has been proven practically by many companies and many teams who have utilized this technique. And there are many studies, online. You can check them about practical and considerations when using pair programming, how beneficial it was in terms of time reduction of time. So also as any kind of collaborative construction, it has all the benefits of making corporate culture, mentoring junior programmers, because if you have a pair and you have a senior programmer and junior programmer together, then there will be some knowledge transfer, right, between from the senior one to the junior one. So we ensure the mentorship, also the collective ownership that we've talked before, because there is no one single person owning the code. It will be a group working together. Also, of course, the quality thing that we have already discussed. So these are the benefits of pair programming. Alright, now we're going to be talking about formal inspections. Okay, what is an inspection? An inspection is a specific kind of review that has been shown to be extremely effective in detecting defects that be relatively economical compared to testing. It is very economical compared to testing, actually. Well, inspections were developed by somebody called Michael Fagan at IBM, and he has been using it for years, and then he published a paper so other people can use it as well. Alright, now we have to differentiate between inspections as a specific sort of review and all other types of reviews. Anything that includes people going through code, and commenting on it is review. But what makes inspections stand out? Well, inspections have many criteria that we can talk about. First of all, inspections must include checklists. Checklists focus the reviewer's attention on areas that have been problems in the past. You don't just come in with just read the code. You have to have a specific checklist as a reviewer to see if something is met or not. This is very important. Also, a very important thing is that inspection focuses on defect detection, not correction. The inspection is not concerned about how to fix a bug or how to fix a defect. It's about finding the defect. This is very important. Also, the reviewers prepare for the inspection meeting beforehand and arrive with a list of the problems they have discovered. So it's not like in the meeting, the first acquaintance of the reviewers with the code is not in the inspection meeting. No, they must have took the code, reviewed it, and then come to the meeting with a list of defects or problems that they think the code suffers from. So this is very important. Other kind of reviews, people will be reviewing the code in the meeting. But in the inspection, people will be review it before the meeting and come to the meeting with the result of their review. Also, the moderator of the inspection isn't the author of the work product under inspection. So the person who actually wrote the code is not the person who's running the inspection meeting, is not the person who's the maestro of the inspection. No. Actually, in inspection, the author of the code has a minor part. Also, the moderator has received specific training in moderating inspections. Now, this is very important in order to have inspections that are effective. You need the person, the moderator, the person who's kind of the manager of the inspection team or the inspection meeting, to have some sort of training on this. Somebody who knows what he's doing. So this is important. Also, the inspection meeting is held only if all participants have adequately prepared. You have major participants in the inspection meeting. You need the moderator, you need the reviewers, and you need the author of the code. If let's say that the reviewer or one of the reviewers having prepared adequately for the meetings, then the meeting is not held, because there will be something missing. So the meeting is held only when all the participants in the meeting have adequately prepared for the meeting. So this is very important. Also, data is collected at each inspection and is fed into future inspections. There will be some kind of knowledge management system. When you get into an inspection meeting and the defects that people found, they can get it and feed it into the system. So in future inspection, there will be something that people can use to find their checklist, right? Because before you review the code, you have a checklist. I'll be looking for this and this and this and this and that, right? So if you have a rich background or rich knowledge base, you can have a broader set of items to look for in the code. That means the code will be more bug free or defect free. So this is an inspection, and these are some of the items that I could say it differentiates the inspection from any other types of reviews. Alright, so what results can we expect from inspections? Well, individual inspections typically catch about 60% of defects. This is high, which is higher than other techniques, except other techniques such as prototyping and high volume beta testing. But the thing is, this has proven to be very effective, because if you have a single technique that can find out about up to 60% of the defects in your code, that means it's very efficient, and this needs to be followed. Also, inspections can be used to assess progress. Okay, so the technical progress of the development phase, or the development of the project in general, can be assessed with the inspections. Alright, so what are the roles during the inspection? Well, we have 4 particular roles, mandatory roles in an inspection. The roles are the moderator, the author, the reviewer, and the scribe. The moderator is responsible for keeping the inspection moving at a rate that is not too fast, because you don't want people just to skip code and not find enough bugs or defects. You need them to go through the code in a thorough way, but at the same time you don't want them to go too slow, so you'll be focusing on just a small part of the code and just waste the time without finding the others. So the moderator is the person who needs to make sure that the meeting is run in such a pace that it's not too fast and it's not too slow. It's like, as I said before, it's like the maestro, the person who's running the whole show. So it's very important. The moderator needs to be technically competent. That means he needs to be somebody who understands technical terms, because when the reviewer explains something or the author replies with something, the moderator, the person who's running the whole thing, must understand what they're talking about. So he has to have a technical background. This is very important. Also, the other role is the author. The author is the person who wrote the code. And in inspections, the author's role should be minimal as much as possible, because the whole thing is about finding defects in code, and the code has to be self-explaining. You shouldn't need the author to explain each and every part of the code. Unless it's something very complicated, then the author is required to explain it. But it is supposed to be, read without the help of the person who wrote it. If the code itself is not written in such a clear way that people need the author to explain each and everything, then the author has to take the code back, write it in a better way or a clearer way, and then get back or make another inspection meeting. So this is important. And well, it goes without saying that the author and the moderator should be separate people. The third role will be the reviewer, and the reviewer will be somebody who has some kind of a contact with the project. but not the person who wrote it. So it's not the author, it's not the programmer, but it can be a tester, it could be an architect, it would be just somebody else who has some kind of, you know, interaction with the project, but is not a person who's actually programming in the project. The reviewer will be the person who's going through the code, finding defects, and filing them in the inspection meeting. The scribe is the person or the job of recording errors that are detected and assignment of action items during the inspection meeting. The person who records all the defects that the reviewers found, and then the person who's supposed to set the action plan in order to fix those defects is the scribe. The thing is, an inspection should have no fewer than 3 participants. Well, it makes sense because the moderator, the author, and the reviewer should be different people, should be separate people, and each and every one of them should attend. You cannot run an inspection meeting without a moderator, or without an author, or without a reviewer. That means 3 is the minimum to actually hold an inspection meeting. And practice showed that 6 people is 6 people is the maximum, or more than 6 people will be too much. So 3 people, from 3 to 6, is the optimal number of participants in an inspection meeting. Alright, we've discussed all the roles during an inspection meeting. How is an inspection meeting held? Now we're going to talk about the general procedure for an inspection. Alright, an inspection consists of several distinct stages. The first of all is the planning phase. Well, in the planning phase, the author, the person who wrote the code, gives the design or code, the thing that to be inspected, to the moderator, the person who's running the meeting. The moderator decides who will review the material and when and where the inspection meeting will be held. This is very important, of course. The moderator then distributes the design or code and a checklist that focuses the attention of the inspectors. Because you assign the code to inspectors, people who are supposed to inspect it, and then you give them some sort of a checklist, you know, the sort of things that they have to focus on in order to make sure that this product is of good quality. It's a good thing that materials that should be, of course, with printed, but with line numbers. So when somebody says, I have a defect, I have noticed a defect in line, and then give him the number, and then everybody would check the number and know what code he's talking about. But if the code, or if the lines are not numbered, then how would he describe it? It would take long time just to make sure everybody knows what piece or portion of code he's talking about. So this is the planning phase. After the planning, we have some sort of an overview. The overview is that when reviewers, you know, are not familiar with the project entirely, because sometimes the reviewers, as we said, reviewers better be somebody who's already kind of involved in the project, somebody like a tester or an architect, somebody who has something to do with the project, but not the coder, not the developer. But sometimes the reviewers are not involved in a project in any way, shape, or form. They know nothing about it. In this case, it would be helpful if there was a small meeting held by the author, the person who actually wrote the code, just to kind of enlighten them on the project. The problem of that would be that he might actually mislead them, because it might be something that he actually described to them and they get as a part of the project, and this part might be the problem itself. So here would be the problem of misleading. But generally, if they have no idea about the project, of course the person who wrote the code must somehow enlighten them. The third phase is the preparation phase. In the preparation, each reviewer works alone on the code or the design and look for errors. This is their job. They are guided by this checklist, the checklist that the moderator gave them, and each one is going through the code against the checklist, just trying to make sure that everything on the checklist is satisfied in the code. Well, sometimes some variations of the inspection is, instead of just looking through all the code just to find errors, you might be focusing on a specific perspective. Right? Of course, you might be like, I'm reading the code from the perspective of a maintenance programmer. Is this code easy to maintain? So you would be reading the code from a certain perspective. Another person would be reading the code from a perspective of a tester. Is this code easy to test? A third person would be reading the code on the same code but on a different perspective, and so on. So each one would be reading the code but on a different perspective. Also, another way would be, instead of reading the code, just all of it from up to bottom, looking for errors, you might be looking at it as in terms of use cases. So it'd be if you have your requirement solicitation right, and then you have your use cases defined, then as an inspector you just have a use case, and then you go through the code to make sure is this particular use case fulfilled. If it's fulfilled, then everything is good, right? If you find while you're following the path of the use case within the code, you feel like something is wrong here, something is not fulfilled, or there is a bug or something, then you record it as an error or the defect. So here's there are many ways of doing the preparation or the work of the inspectors themselves. After all the inspectors have done their job, everybody's prepared, everything is good, then we hold an inspection meeting. Well, the inspection meeting is held by the moderator, is called for by the moderator, and the moderator calls somebody, the scribe, the person who actually records all the errors or the defects that people noticed. The thing is, in this meeting, in the inspection meeting, it should never be about solutions. You should not talk about how to fix the problem. You should not talk about the possible ways this problem should be handled. No, you just point out the defects. This is the whole purpose of the problem, of the meeting, just to point out defects. Again, because this is very important, do not discuss solutions during the meeting. The group should stay focused on identifying defects. That's the whole thing. Alright. After the meeting, then we have the inspection report. Well, actually within a day of the inspection meeting, after the inspection meeting is done, and within a day from that, the moderator produces an inspection report, like an email or something he sends to all the parties, the inspectors and the author. This email or this document lists each defect that people found, each defect the inspectors found, accompanied with the severity of this defect, and then this is sent to all the interested parties. The sending of this email, the purpose of preparing this report and sending it is to help to ensure that all defects will be corrected, because you have to log what people found, right? Because if it's just talking, nobody will remember it. And you will have your own checklist that emphasizes problems specific to the organization, because it might be some sort of an organization specific errors, because you notice that if you have this kind of report and then you have some kind of a knowledge base, you add these records to it, and if you analyze it, you might find that certain developers within the company fall or do certain problems, or certain defects are produced. So this might be something that you'd like to you'd like to fix, right? So this is the meeting, the report. The report is prepared within a day after the meeting is done, and all the defects that were logged by the inspectors are set on the report, and then it is emailed to all interested parties. Well, after sending the report, then there is the rework phase, because all the defects that we found on the code has to be reworked, right? It has to be fixed. So the moderator assigns defects to someone, most probably the person who actually wrote the code in the first place, the author. You assign him that these are the defects, these are the bugs, you have to fix them. This is the rework phase. And then you follow up. The follow-up is the job of the moderator. The moderator is responsible for seeing that all the work necessary, all the defects or the bugs found has been fixed. You would be following up. Okay, what happened now? What happened now? How much percentage of the work you have to do has been done already. You have to follow up with the author or the person who's fixing the defects. And sometimes, if the project itself is sensitive, or if the magnitude of the defects found is huge, then you might need to re-inspect it. Hold another inspection meeting and go through the code again, just to make sure that everything is fixed now. This is called the follow-up. Alright, we're going to wrap up our work on practices and collaborative development. Well, we first talked about the practices overview. We talked about practices itself, why do we need it. We talked about how it completes other quality assurance techniques, and how about it provides mentorship, and we talked about collective ownership. Well, we then discussed pair programming, and we talked about keys to successful pair programming, stuff that we have to do in order to achieve actual successful pair programming. Stuff like having code standards, having it's not about just watching. People should contribute, not just watch. We talked about we don't need easy stuff. It has to be applied only on difficult or complicated matters. We talked about we need people who can actually work together. You shouldn't put people who hate each other in the same team and stuff like that. We also discussed the benefits we gain from pair programming. We then turned to inspections. We talked about inspections in terms of what are inspections, the results, the stuff that we can expect from inspections. We talked about the different roles in the inspection process, and we talked about the procedure at which inspections take place. And now chapter 21, collaborative development, is finished. Thank you very much for tuning in.